In this session, I'm going to walk through how you implement a smart contract for what's known as a crowd sale, also known as a token offering, also known as an ICO. Let's start with a recap of where we ended yesterday with a very basic token implementation in Solidity. So this is super simple. It fit on one slide. There's a name for a contract, and the contract is defined with the term contract. I called my contract GB token. We talked about the fact that at its very core, a new cryptocurrency has to keep track of balances for all accounts on the blockchain. We do that with a simple data type with a variable called balances. It has a data type of a mapping, and it maps addresses in Ethereum to an unsigned integer, a uint, which represents how much in terms of number of tokens that user has. There's a constructor. Every contract can have a constructor. What it means is when this contract is deployed, what are the initial configurations of that contract? You get to define what this constructor looks like. It doesn't always need this input of an initial supply. I wanted my token to have an initial supply, so I gave it an input. And in programming languages, in all programming languages, in most of them, and especially in Solidity, the syntax for defining an input parameter for a function is just after the function name. In this case, the constructor is the function signature. You have not the curly braces, but the round braces with the name of the parameter. So that's initial supply. I use that initial supply to give my contract creator the address of that contract creator, which is defined in message.sender, msg.sender. I give initial supply number of tokens to that initial sender. Then I define two behaviors. One updates the state of the blockchain. It's the send tokens function. The other simply reads the current state. It's called get balances. And I think you can understand what's happening here. Send tokens deducts tokens from the sender and increases them for the receiver. Get balances simply reads the mapping variable that we have and instantly returns the number of tokens held against that address. We are going to extend this contract. Our goal now is to do what's known as a crowd sale or a token offering. Have you guys come across any crowdfunding campaigns on Kickstarter, Indiegogo, any of these sites? Has anyone used Kickstarter? Has anyone run a campaign, donated to a campaign? You give money. You give it in any currency of your choice, dollars, rupees, whatever you want. And typically they give you something in return. So it's something of value. That's what we need to talk about. It's something of value. It's like, hey, you give me $10, I will give you something of value. For example, it could be a physical object. Like I will give you, so if I'm selling the first ever VR headset in the world, or let's say AR headset in the world, and I'm running a crowdfunding campaign for my AR headset. I say that, hey guys, rather than going to traditional investors who are going to take a lot of equity from me, why don't you give me some money? And depending on how much money you give me, I will give you either the first headset I ever make, or I'll give you a special coupon code for a headset you can buy in the future. It can take any format. It could be a physical object that I send you later. It could be a piece of paper that says you have the right to obtain this object later. As long as it's something that has value either today or will have value tomorrow. Do we get that? Because it has to be a balanced exchange. In the blockchain world, crowdfunding exists as well. Projects that want to work on anything of their own, they could choose to run a crowdfunding campaign where the donators in this case, the people giving money or contributing money not in dollars or rupees, but in a cryptocurrency, in Ethereum. Why Ethereum? Because typically these projects are building their project that they're raising money for on Ethereum. So they're saying, hey, we're going to build you something on Ethereum. You give us money in Ether. What do they give in return? So some of you said it. I think the hint is pretty obvious. We're talking about tokens. They give a token in return. I'm using GBT, referring to GB token, which we have been working on. Yours can be called anything you want. But the idea is you give a token back. Now, does a token have any value right now? Until you have a very first exchange or some individual who says, I'm accepting GB token, and I will give you XYZ, it doesn't have value. Value in our society comes from people believing that something has value. It's belief. And so until tokens have belief, they don't have value, which is why this is a very delicate situation. When you, as an investor, decide to give Ether and accept a token, you need to decide, okay, today this token has very little value. Tomorrow, how much value would it have? Right? And if you believe it has value, then you would put in a proportional amount of Ethereum. And there are many ways of doing that math. We will keep things very simple now. And in our example, one token will be equal to one Ether. Okay, that's a very unlikely scenario, but one token that we create right now is going to be equal to one unit of Ether. So if I give one Ether, I get back one token. This is called a token offer. Time to figure out how the information flow works on the blockchain for implementing this logic. We're going to go through a few steps, understanding how it works. And we are going to use the simplified virtual machine that Remix gives us as our blockchain platform. So in this blockchain platform on Remix, you remember that when you go into Remix, you can choose JavaScript VM. It by default creates 5 accounts for you. I have shown those 5 accounts in this browser. My golden box represents browser, and each of them is initialized with 100 Ether. This is arbitrary. Remix gives me this. These are 5 different user accounts, external user accounts in my virtual machine. And now we're going to look at what needs to happen for a full flow to work with the token offering. The very first thing is one of these accounts has to deploy a contract that does the crowd sale. So let's say that first account is going to be the creator of the contract. And what that account does is it submits a transaction to the blockchain that creates a new contract, which also has an address because contracts also have an address in Ethereum. And that's located at a different address. It has by default no balance, and it's called GB token and Crowdsale.sol. That's what we will be implementing today. One of these accounts deployed it. That account, you notice its Ether balance got reduced very slightly because it paid a transaction fee. Okay? Realistically, it'll be 99.9999999, something like that, because you paid a very small fee. Next step. You remember that our token contract by default takes the person who submitted the contract and gives that person the entire supply of tokens. So we're going to call this contract and the owner, this address, we'll call this address the token fund. Let's just call it that. This token fund has been initialized with 1,000 GB tokens. Now, let's do our crowd sale. Let's say that the other 4 accounts represent people like you and me. And 2 of them care about GenerationBlockchain token. They want that token. And the token fund address, the person who created this crowd sale, he or she, let's say it's me in this case, I'm this first account. I created the crowd sale because I want money to invest in the creation of GenerationBlockchain's content. Right? We're using a real world scenario here. I want money today to start making fancy videos, to run more courses, to invest. And that's why I want your money today. And I'm giving you a token which will be valuable to you tomorrow. So what happens now is 2 of you are convinced that you want this token and you're willing to donate, or not donate, but rather give money to this cause in exchange for that token. So 2 accounts now give 10 Ether each and their balances get reduced to 90. And the balance on the contract gets incremented to 20. Our logic that we will implement will return to these users 10 GBT each because we have fixed the token price in our contract to be equal to 1 Ether. And we got 10 Ether, so we give 10 GBT back. We give 10 GBT back to both, and we decrement the token fund just so that we're not being fraudulent. We're not minting new tokens. We're sticking to our promise that this is a fixed supply token. So 980 tokens left in the fund, 10 given to second account, 10 given to the 5th account. And I have 20 Ether in the contract. There's only one more step left. The last step is, let's say I say, okay, you know what? All I needed was 20 Ether. That's good enough for me. I'm going to end this crowd sale. I need to, so that money sitting on a contract is not with me. I created the crowd sale. I need to get it back. That's the final loop, final part in this loop of a crowd sale. I need to create a function in my contract that allows someone to submit a transaction. make sure that the person submitting that transaction is indeed the person who created the contract, who ran the crowd sale. Only he or she, in this case only me, should be able to take these funds back. I will remember this because in our code we're going to have an if statement that checks. So we create a function to which I submit a transaction. The same account, submits a transaction saying withdraw raised funds. That's what we'll call it. As you can imagine, that last part is take the Ether balance of the contract and send it to me. So what happened to me? My Ether balance is now increased to 129. Oh, I should be, I think, 119. Should be 119. Yeah. I'll fix that in the slides I sent out over Slack. So that should say 119.98 Ether, and the contract's balance goes to 0 Ether. All right? Everything else stays the same. So let's look at the before and after in our crowd sale scenario. When we started out, I, the person trying to raise funds for a project, have some money. I'm trying to raise money. By the end, I have raised 20 Ether. Again, that should say 119.98. I have raised 20 Ether. 2 people have donated to my campaign or given money to my campaign, so their Ether balances have been deducted. Account 2 and account 5, deducted from 100 to 90. And in exchange, the 2 of them have gotten 10 GBT each. That is a full token offering. All right. Should we walk through some code? All right. Switching to GitHub, and I have the code open. Can you guys see this? Again, it's on GenerationBlockchain. So you go to github.com/GenerationBlockchain, and the project is called Remix Tutorial Simple Contracts, GB token and crowdsale.sol. So I'm going to go through it. So I create a new contract and I name it GB token and crowdsale. I'm implementing this crowdsale on top of my existing contract. You can always have a separate contract called crowdsale, which interfaces with your other contract called your token. We're doing this for simplicity. It's just easier. But on your own, you can try implementing it a different way. So this contract still has the balances array. Still has balances because it's still representing, it's still storing the state of different tokens on different addresses. Notice that, we had in the slides created this concept of a token fund, which is the initial deployer of the contract. That is the address we are designating as the holder of the token funds. This address will store that in the constructor. I then have this concept of a beneficiary. In my example, I, the person who created the crowd sale contract, am in fact the one who's trying to raise funds. But imagine a scenario where the person that wants the money in the end, the organization, is using a different address for their Ethereum wallet. So they want the money that's raised in Ether to not go to the person who deployed the contract. Maybe the person who deployed the contract is a developer, let's just say, has his own developer address. They want to have a beneficiary who will receive the funds, and that address could be the same or different from the token holder. Does that make sense? Money goes into a pool of Ether. Ether, whenever the crowd sale ends, goes to the beneficiary. Beneficiary is the person who will receive the funds and is the only address who will be allowed to receive the funds. You can implement this however you want. I could have made this an array of beneficiaries, meaning anyone in that whitelist can receive the funds. It's up to you how you structure it. Okay, I could have said address CEO, address CTO, address CFO, and then later on said if message.sender equals CEO or equals CFO or equals CTO, do it. You can do whatever you want. I've made one beneficiary. Then I keep track of how much I have raised at any given point in time. This is just an integer, unsigned. It's going to be increased each time I receive. So when I received 2 transactions with 10 Ether each, I would increase by 10 and then increase by 10 again, and you'll see where this happens in the code. We fix the price of a token, in this case GBT, to 1 Ether. And because these values need to be stored in Way, the way you can do that easily is 1 times 1 Ether. This part represents the equivalent amount in Way. It's a big number. All right, we are going to skip this part because we haven't talked about it yet. I'm going to come back and talk to you about what events are and why they're so awesome. And just a hint, it has to do with the topic one of you guys raised, which is how do you pool a blockchain? Someone asked in the last session, how do I poll? How do I find out the state of my transaction? How do I know when something that I wanted to happen is actually done? That's where events come in. You can emit events from your contracts and watch for them or listen for them outside. I've created 3 events, and one is going to be called when I transfer funds. We won't use that here. That's for my token activities. Funds raised is fired every time, is going to be emitted every time I receive funds, and funds withdrawn will be fired whenever the beneficiary has received their funds. So now we have a constructor, and it's only 3 lines of code. Everything you see here is a comment. Everything you see with the double slash is a comment. The first line does what you've already seen. It says that the token fund should receive all my initial supply, and that's given by message.sender. The second line says, hey, in this case, we want that same person who deployed the contract to be the address of the funds. And the reason I need this is I'm going to refer to this variable later. So I save a reference to it. The final step is I have created a beneficiary address. And in this case, I'm saying the beneficiary, the person who will receive or be allowed to receive my ether that's raised, is the token funds person. The first account that created the contract, he is the only one that's allowed, in this case, to receive the ether balance. Let's copy this to Visual Studio and code there. In fact, I think I may already have it. Yeah, I already have it. Let's go down. Send tokens, you've already seen this method. I've just added an event at the end that I'm emitting when tokens are transferred. Get balance, you've already seen this function. No change. It's just for the token, for viewing what is the state right now and who has how much. There are 2 functions we're going to discuss now. One is called buy tokens with ether. Can you guys see it in the back? Okay, one is buy tokens with ether. And I want you to notice one thing here. It has the keyword payable. We talked about this briefly yesterday. The modifier payable means you can send ether to it. For our crowd sale to happen, people have to be able to send ether value as part of their transaction to our contract. And they will invoke the function buy tokens with ether with a value. And I'll show you how this works on Remix. Inside it, I'm doing a couple things. I first use my price of the token, which is fixed, and the value that was sent to me as part of this transaction, and I compute the number of tokens that I need to give the person who just called this function. I then reduce those tokens from my token fund, and I add them to the person who just gave me ether and now needs my tokens. I then do what I need to do in order to know at the end how much I've raised, which is to increment my amount raised variable by the amount that was raised in ether. And then I made an event saying funds raised. Last function. This is very simple. Last function. Withdraw raised funds. Step 1, make sure that the person who is calling this function is the beneficiary and nobody else. If it's anyone other than the designated beneficiary, return out of this function, which means don't do the next few lines of code. And then finally, there's a built-in function you can call on any address in Solidity. Beneficiary is an address, right? It's an address. We declared it as data type address. Has on an address data type in Solidity, you can always call the transfer function. It's built in. So .transfer means exchange ether or send ether to this person. And how much am I sending? I'm sending amount raised. Finally, I emit this event. I want to show you that this works as promised. So let's take this and let's paste this in Remix. So I go here and I think this is the same, but just in case I'm going to paste it and I'll do this, minimize this so you can see. All right. This is the function, this is the contract that we've just gone through. It is auto-compiled and that green thing means it has compiled. Let's go to run. So let's just do this quickly, very quickly. We have a token in Crowdsale. I'm using, I don't want to use that, I want to use my VM. It creates 5 addresses. There they are, 5 addresses. And let's just make our first one be the one who's going to create the contract and deploy it. Notice that my contract has an initial funds, initial supply. I'm going to create 1,000 tokens. All right? When I hit deploy, it deploys the contract in memory. So you can see the address here where it's deployed in memory. And just to make sure that it has 1,000 tokens, let's take the address of this account, copy it here, by clicking this button and come down here and use our get balance function and paste the address and see how much we have. It says I have 1,000. So all good so far. That code worked, the constructor worked. I am initialized with 1,000. I am the token fund. What's next? 2 people have to send it money, right? So let's do that. Let's just, for now, for demo's sake, I'm going to take the last account and I'm going to submit a transaction with 10 Ether, right? This says Wei by default. Let's change it to Ether. I'm going to send 10 Ether, which is fine because I have 100 Ether in this account. This is my last account. The way I call a payable function is after I've specified 10 there, I just click the function here. So I think the function was called buy tokens with Ether. So I click that. All right? And you guys can't see this because everything is so zoomed in, but here I have a console which says buy tokens with Ether pending, and then when it shows me this, it means the transaction has gone through. So what's the balance of that account? 89.99999 because 10 has been sent to the contract and then a small transaction fee. Everything makes sense? Yeah? Okay. What's next? You want to check how many tokens this person has? This person should have how many tokens? 10, right? Let's see. So let's copy the 5th address and call get balance on the 5th address. 10. We're good so far? Good. Second person? Okay, second person will send. I go here, I type in 10 Ether, and I call buy tokens with Ether. This is the second person participating in my crowd sale. Boom. Pending. And notice this is instant in the console. If I publish this contract to Ropsten, the test network, everything would take longer. We're doing this on a personal blockchain. It's very quick. So now let's just test that the second contract, okay, second contract also has 89.99999. Let's just copy that address, check the balance on that. It should also be 10. Okay, it's 10. So last step, guys, just to show you that this works, is I go back to my first account because I have to send this from that first account because beneficiary is that first account. You could even have a function that says get beneficiary and have it print out just to show you that the beneficiary address is indeed 0xCA3, whatever. But anyways, we go here and we go to withdraw raise funds and let's cross our fingers, hope that it works. Something happened. 119.99999. All right? I think now we should do a round of applause for the smart contract.